Welcome back, students. Today we're going to be talking about function operations. That is, we are going to be taking our functions, such as f of x, g of x, things like that, and we are going to be combining them using addition and subtraction. So right here, you'll notice this statement where we have f and g. So both of these are the names of the function f and the function g. Then you got the parentheses over here. These parentheses are to say what the input of both of those functions is going to be. So x is going to be the input of both of these functions. This statement right here can be rewritten as just saying f with the input of x plus g with the input of x. Now we already know what f of x is equal to. F of x was a 3x minus 9, g of x a 5x minus 7. So we already know what both of those should become. So f of x, I'll replace it with 3x minus 9, plus the g of x, which should be 5x minus 7. Okay, and now that we've done that substitution, we can just combine our like terms. 3x's plus 5x's leaves us with 8x. Negative 9 minus a 7 gives us negative 16. And this is f plus g of x. Okay? All right, so in this next one, we notice we've got a minus sign. That's going to create a very subtle difference in one of these steps. Now, I'm going to go ahead and change this. I kind of like the... Okay, paused on me for a moment. All right, so I prefer the notation of saying f of x and then minus g of x. In other words, just saying that x is the input of the f function. X is also going to be the input of the g function. That being said, I now know exactly what to put in for both of those. So f of x was a 3x minus a 9, and then g of x is a 5x minus a 7. Now, I'm going to do a little something extra. I'm going to put parentheses around g of x. The reason I'm doing that is I was subtracting all of g of x. Now, g of x had two things in it. If I don't put those parentheses, it looks like I'm just subtracting 5x, when really I should be subtracting everything inside of g of x. So this minus sign is going to distribute to both of those. So we're then going to have 3x minus 9 minus the 5x, and then minus a negative 7. Subtracting a negative is just like adding. And now we've got that. So now 3x minus 5x will be negative 2x. Negative 9 plus 7 is a negative 2. And that's how we subtract. All right, now, in this next one, notice what's making this one slightly more difficult. We've got these numbers that are multiplying the function. So we've got 2 times g and 2 times the f. So as I rewrite it into the notation that I kind of like, so I'm going to put this as g with the input of x minus 3 times f of x. And we, of course, already know what those should be. So I'm going to change this to 2 times. And once again, I'm going to put parentheses. The reason I'm putting parentheses is similar to before. I wasn't just multiplying the 5 in g of x. I was multiplying the entire function of g of x. So as I do this, I need to make sure to put those parentheses so that that will get distributed through as well. All right, and now that we've done that, notice the 2 is still there. All I did is I replaced g of x with what g of x was equal to. I replaced f of x with what f of x was equal to. And now I can substitute, or now I can distribute. So 2 times 5x is 10x, 2 times 7, negative 14, negative 3 times 3, negative 9x, negative 3 times negative 9, plus 27. 10x minus 9x is just 1x, and negative 14 plus a 7 plus 27, sorry, is going to be 13. And there we go. In these next problems, let's see, there it goes. Sorry, getting it to scroll is not working very well. All right, now you probably noticed I had some tables up here. I'm going to ignore those for just a second. I want to come down here and I want to do one of these problems, and then we'll see why those tables can, under certain circumstances, be very helpful. So notice that the big change here is that we don't have x in there. The input is now considered to be a negative 1. So this would be written as f of negative 1 plus g of negative 1. And we're still using those same equations as before. So since f of x was a 3x minus 9, as I come down here, I'm going to rewrite this as 3. But then, rather than x, notice we had this 1 in here. Okay, so I'm going to have 3 times negative 1 minus 9. And so there's my f, and now for g, we're adding them together. I got my plus. We then had 5x, which the new input rather than x is a negative 1. Notice the big change is really just that I'm changing the x to whatever was inside those parentheses, to whatever the new input is. All right, so now doing that, 3 times negative 1 will be negative 3 minus 9. 5 times negative 1 will become negative 5 minus 7. 3 minus 9, negative 3 minus 9 will be negative 12. Minus 5, negative 17. Minus 7, negative 24. Okay. So this is certainly one way of doing it, and it's perfectly valid. Now let's look at this g minus f of 1. So I've got these tables up here. We're going to use these tables to help do that problem a bit faster. Now, of course, filling out a whole table to do that problem isn't faster. Where a table makes it faster is if you're going to be using the same equations repeatedly, or if you're using some type of device, such as a graphing calculator, to create a table for you, then all of a sudden these problems can be very easily done so long as you've got that table made. In order to show that, let's go ahead and fill in these tables. So this is our equation of f of x, 3x minus 9, and we're being given different values to put in for x. So we have 3 times a negative 1, minus 9, a 3 times a 0, minus a 9, a 3 times a 1, minus 9, and a 3 times a 2, minus 9. All we're doing is changing the x in the equation to the input number it gives for us. So that'll become negative 12, negative 9, negative 6, and negative 3. All right, over here we'll do 5 times negative 1 minus 7, 5 times 0 minus 7, 5 times 1 minus 7, 5 times 2 minus 7, which is then going to give us negative 12, negative 7, negative 2, and 3. This next one, we've got a square. Just remember that when a number is multiplied, that a squared means to multiply it by itself. That's what that exponent is saying. So we're going to have 3 times negative 1 squared minus 9, 3 times 0 squared minus 9, 3 times 1 squared minus 9, 3 times 2 squared minus 9. So negative 1 squared is 1, 1 times 3 is 3, 3 minus 9 will become negative 6. 9, negative 6, 2 squared is 4, 4 times 3 is 12, 12 minus 9 is 3. All right, so now I've got these tables. Now remember, and I wanted to show me filling out those tables because I wanted to re-emphasize what we're doing when you evaluate a function. So for example, if you're asked to find what f of negative 1 is, that's what we just did. F of 0, that's what we just did. F of 1, that's what we did. That's all these tables really are. They show us those values for f of x, okay, depending on what number you used as an input. So now here's how to use a table, either made by hand or made by a graphing calculator. So this I would change to g of 1 minus f of 1. Well, I know where g of 1 is. G of 1 is right here. It's a negative 2. F of 1, it's right there. It's a negative 6. So I'm going to have a negative 2 minus negative 6, which should be equal to 4. So notice how much faster that one went than the previous. I already knew what the numbers were because I already had them in a table. And each of these can be just that easy. So let's look at this next one. We're going to have f of 0 minus g of 0. So we've already figured those ones out. F of 0, g of 0. So negative 9 minus negative 7. Negative 9 minus negative 7. And that's going to equal negative 2. All right, next we've got h of 2 and g of 2. So there we got g of 2. That one would be h of 2. And h of 2 was 3. G of 2 was also 3. So now the problem is just reduced to what's 3 plus 3? 6. Okay, once again, we already did the substitution steps that we had shown in the previous one. So now it was just a matter of, I know what h of 2 is, I know what g of 2 is. Add the numbers together. Now, if you don't already have a table made, or you're not using a graphing calculator to make one, this method right here is your best bet. This is what you should do. However, if you are going to be using the same equations over and over and over, just with different values, maybe you want to make a table. Okay? In this last one, notice what the new input is. The input is not an x, and it's not even just a number. It's a whole algebraic expression. That, however, does not change much for us. So we're still going to have f of, but rather than x, we've got 3x minus 1 plus g of 3x minus 1. Okay, and so what I'm going to start doing is writing the equation for f. Well, f was a 3x minus a 9. So I'm going to write 3, but then where x normally would have gone, we don't have x. We are substituting x with the new input. The input, 3x minus 1. Okay, so f of x, let's see, it was 3x minus 9, so I've got my 3, that's replacing the x, minus 9, plus g of x had 5x, so I'm going to put 5. We're changing our x input to the 3x minus 1 that they gave us up there, minus 7. Okay, and now we can just distribute like we've done before. And then combine our like terms. And we have our answer. All right, I hope this helps. Good luck.